For as long as human beings have looked upward, we have wondered whether our solar system is unique or just one small part of something endless. The question is as old as thought itself, written in the patterns of the stars that early travelers once used to find their way across oceans and deserts. We built stories around those lights, not only to explain where they were but also to understand who we were. Every culture saw something of itself in the sky, its hopes, its fears, its rhythm. But behind every myth and every name given to a constellation, there was always the same quiet question. Are we alone, or are there others out there circling their own suns, wondering the same thing? When scientists first began to study the heavens with precise instruments, the solar system was the only example we had of how planets formed and moved. The Earth, the Moon, and the wandering points of light we call planets became the template for what we imagined existed elsewhere. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, each world with its own rhythm, its own landscape, its own secrets. For centuries they were all we could see, all we could measure. We knew their distances in miles, their paths in days and years, their sizes, their masses, their strange and beautiful colors. Yet, even as we learned these details, we still did not know whether any of it was typical. We had only one example, the one we lived inside. The scale of the solar system itself is enough to make the mind grow quiet. From the Sun to Neptune stretches nearly 6 billion miles, and beyond that, the icy fragments of the Kuiper Belt extend even farther, into the dark edges of the heliosphere. Light from the Sun takes about 8 minutes to reach Earth, but it needs more than 4 hours to reach Neptune. These distances are not just numbers, they are measures of time and patience. Everything in our solar system moves slowly, following paths drawn by gravity and history. To study such a place is to learn to think in scales beyond a single lifetime, beyond a single human story. And yet, we do it because somewhere deep in us there is the need to understand where we belong. When the first telescopes turned toward other stars, what they saw was light alone, steady, distant, unchanging. Stars twinkled not because they moved, but because the Earth's air made them shimmer. For centuries we could only guess whether those points of light had planets. It wasn't until the late 20th century that our tools became sensitive enough to detect tiny changes in brightness, small wobbles in a star's motion, subtle dips in its glow that might mean a planet was crossing in front. The discovery of the first exoplanets, the first worlds beyond our solar system, transformed our understanding almost overnight. Suddenly we knew that planets were not rare, they were everywhere. Yet even with thousands now known, the question remained, is any system like ours? Our solar system has something both simple and special about it. The inner planets are small and rocky, close to the Sun, their surfaces solid and shaped by volcanoes, wind, and water. The outer planets are large and gaseous, surrounded by rings and moons that make them look like miniature systems of their own. Between these two regions lies the asteroid belt, a boundary of stone and metal that seems to divide the system into two great families. This structure gives us stability. It allows Earth to exist in a zone where liquid water can flow, where temperature and light remain balanced. The same pattern may not exist everywhere. Some systems we have found are wildly different, giant planets closer than Mercury, or worlds circling stars in strange tilted orbits. It makes us wonder whether our balance is a rare gift or just one of many possible designs. The more we learn, the more delicate our solar system appears. Each planet's orbit depends on every other, all linked by the faint pull of gravity. If Jupiter were much closer to the Sun, its influence might have scattered Earth's orbit long ago. If the Sun had been slightly less massive, the planets might have formed differently or not at all. Our existence depends on a chain of conditions so specific that it feels almost improbable. And yet, improbability is the rule in nature, not the exception. The universe has room for endless variations, and what seems rare to us may be common when measured across billions of stars. Still, to truly know, we would need to travel beyond the limits of our sight, to see other systems up close, to touch their worlds, to compare their skies to our own. But that simple wish, to go and see, is far from simple in practice. The distances between stars are vast beyond intuition. The nearest star system, Alpha Centauri, lies more than 25 trillion miles away. Even if we could travel 1,000 times faster than the fastest spacecraft ever built, the journey would take tens of thousands of years. It is easy to imagine crossing the galaxy in fiction, but in reality, every mile between the stars is a challenge written in the language of physics. Light, the fastest thing we know, needs over 4 years to travel from the nearest star to us. We live in a universe where space itself is the greatest obstacle. Understanding how planets form and evolve has become one of the central questions of modern astronomy. We now know that stars are born in great clouds of gas and dust, where gravity slowly pulls material together until nuclear fire ignites at the center. Around these new stars, the leftover dust flattens into a disk, where particles collide and stick, forming larger bodies, planetesimals, then protoplanets, and finally worlds. This process happens everywhere, across billions of light years, guided by the same laws that shaped our own sun and planets. But even if the laws are universal, the results are not. Tiny differences in temperature, composition, or timing can lead to completely different systems. Some stable, some chaotic, some filled with worlds that could never support life. Our solar system is calm now, but it was not always so. In its early days, countless collisions shaped it, worlds forming and shattering, orbits shifting, moons captured and released. The smooth paths we see today are the result of billions of years of settling, a long and patient dance toward balance. When we look at young systems in the galaxy still surrounded by clouds of dust, we are seeing what our own home once was. A place of constant creation and destruction, of motion and transformation. It is humbling to realize that the peace we see now is not permanent, but a phase in a much larger story. The challenge, then, is not only to discover new systems but to understand how they came to be. The instruments we use, telescopes, spectrometers, space observatories, can capture only light, only hints of what is truly there. We study those hints carefully, interpreting them through physics and mathematics, building pictures of places we cannot visit. The James Webb Space Telescope, with its deep infrared vision, can peer through clouds of gas and reveal disks of forming planets hundreds of light years away. Each image is like a glimpse into our own past, a soft echo of how our solar system might once have looked. But even these glimpses raise new questions, each answer unfolding into another layer of mystery. When we speak of exploring the universe, we often imagine grand voyages, ships traveling between stars, new worlds being discovered, civilizations meeting across the void. But before any of that can happen, there is a quieter kind of exploration that must come first. It is the exploration of understanding, of looking inward as much as outward. We need to learn how to see clearly, how to measure without assumption, how to recognize patterns in the silence. This is what astronomy truly is, the art of listening to light, of finding meaning in the faint signals that reach us across the dark. The more patient we become, the more the universe reveals. Even now, we can sense how fragile and interconnected our system is. The sun, the planets, the moons, the comets, all part of a single structure held together by gravity and time. We live within it as fish live within the sea, rarely noticing the medium that supports us. Every sunrise, every shadow, every tide is a result of this cosmic relationship. The same gravity that holds your feet to the floor is the same force that keeps Earth in orbit and guides the moon across the sky. It is the same law that binds the stars of the galaxy together, and the same one that keeps galaxies orbiting one another in quiet spirals. In that sense, the universe is not many things, it is one thing, continuous and whole. And so, as we look outward, we are also looking back at ourselves. To ask whether our solar system is unique is really to ask whether our story is special, whether the combination of order and chance that created life here could happen again elsewhere. It is not an easy question, and it cannot be answered quickly. The distances, the time, the limits of our tools, all make it a challenge that stretches beyond generations. Yet that is what makes it beautiful. The search itself is an act of wonder, a quiet declaration that even in a vast and silent cosmos, curiosity endures. We are small, but we are not without reach. Our minds, like our instruments, are drawn outward by the same gravity of mystery. To explore these questions is to face the boundaries of what we can know. We have maps of our own system that reach to the edge of the heliosphere, but beyond that, we have only guesses and patterns of light. The next steps require patience, technology, and a kind of faith, not religious faith, but the quiet trust that learning takes time, that the unknown is not hostile, merely distant. We are just beginning to see the outlines of other systems, to sense their differences and their similarities. Slowly, through careful observation, we are learning to place our solar system in context, to see it not as the center of anything but as a single note in a universal song. And yet, even as we learn more, the feeling of wonder does not diminish. If anything, it grows. To realize that there may be countless systems like ours does not make ours less beautiful. It makes it more meaningful. It means that the laws that shaped our world are not ours alone. They are shared across space and time. It means that we are not isolated but connected, part of a vast process that continues everywhere. Whether our solar system is unique or not, it has given us the gift of awareness, the ability to ask the question at all. That, perhaps, is its most extraordinary quality. As you think about this, you can feel how the mind begins to slow again, how the edges of these thoughts soften into calm. The distances we speak of are so vast that they almost defy comprehension, and in that vastness there is peace. The universe is patient. It has waited billions of years for us to look up, to wonder, to begin to understand. And now, with that same patience, it invites us to rest and to listen. The story continues, but slowly, as all cosmic stories do. The first challenge awaits, the one that defines everything that follows. The limits of distance, the barrier of motion, the physical reality of space itself. When we think about space, we often imagine distance as just a number, something that can be measured, crossed, or mapped if we simply travel far enough. But in reality, distance in space is not just about how far something is, it is about time, energy, and the unchanging laws that govern how motion works. Every mile that separates one world from another carries with it a cost, not in money but in effort, in patience, in the very nature of physics itself. The universe is vast not only because it is large but because it is slow to yield to movement. To travel across it is to learn how small even the fastest motion can seem when measured against the scale of the stars. The first limit we face is the simple truth that space is enormous beyond intuition. The moon, our nearest neighbor, lies about 238,000 miles away, and light itself takes a little more than a second to cross that gap. The sun, the heart of our solar system, is 93 million miles away, and its light takes just over 8 minutes to reach us. That light moves at nearly 186,000 miles per second, the fastest thing known in the universe, and yet even at that speed it needs over 4 years to travel from the nearest star, Proxima Centauri. If we sent a spacecraft moving at the speed of our fastest probes, it would take tens of thousands of years to reach that same star. These numbers are not just facts, they are quiet reminders of how gently the universe insists on scale. When we look at the distances between planets, we begin to sense this scale in a way that words cannot fully express. Earth's orbit is a delicate path that takes 1 year to complete, and in that time, our planet travels nearly 600 million miles around the Sun. Yet even so, to reach Mars, our closest planetary neighbor, we must cross tens of millions of miles of empty space. That journey takes months not because our machines are weak, but because space itself does not allow shortcuts. There are no roads, no rails, no medium to push against. Every inch of movement must come from the energy carried with the spacecraft. To move through a vacuum is to move against nothing, and yet, paradoxically, that nothing resists through sheer scale. Propulsion, in its most basic sense, is the art of exchanging energy for motion. Rockets move because they throw mass in one direction, pushing themselves in the opposite. This is not a flaw or a limitation of design. It is simply the way nature balances force. But this balance means that speed must always be paid for in fuel, and fuel has weight. The faster you want to go, the more fuel you must carry, and the more fuel you carry, the heavier your craft becomes. It is a quiet trap built into the physics of motion, a kind of cosmic symmetry that keeps ambition tethered to reality. Every extra mile per second costs exponentially more energy, until, very quickly, the cost becomes impossible. The Apollo spacecraft, which carried humans to the moon, reached speeds of about 25,000 miles per hour when leaving Earth's gravity. At that speed, it took about 3 days to reach the moon. But even if you could maintain that same speed toward Mars, it would take months. Toward Pluto, it would take nearly a decade. Toward the nearest star, at that same speed, it would take over 100,000 years. These numbers are not discouraging, they are simply the way the universe defines scale. They remind us that the solar system, for all its quiet beauty, is not a small neighborhood. It is a vast ocean, where motion is measured not in hours or days but in lifetimes and generations. The concept of escape velocity, the speed needed to break free from a planet's gravity, is another limit we live within. For Earth, that speed is about 25,000 miles per hour. For Jupiter, it is more than 130,000. To escape the Sun entirely and drift into interstellar space, a spacecraft must reach nearly 380,000 miles per hour. These speeds are unimaginable in our daily experience, and yet even they are tiny compared to what would be required to cross the galaxy. Gravity holds everything in place, not as a cage but as a quiet reminder that all motion requires balance. The same force that allows us to stand, to orbit, to exist, also slows our attempts to move beyond it. Imagine trying to cross a field of distances so great that even light, the fastest traveler in existence, seems slow. When we look at the stars, we are not seeing them as they are but as they were, years, centuries, or even millennia ago. The light from the nearest bright star, Sirius, began its journey toward us over 8 years ago. The light from the Andromeda Galaxy, visible on clear nights as a faint blur, left that galaxy more than 2 million years ago. Every point of light in the sky is a message from the past, traveling at the universe's top speed, and still, it takes eons to arrive. In this way, distance becomes not just a measure of space but a measure of time itself. The speed of light, often thought of as infinite, is both astonishingly fast and deeply limiting. According to the laws of physics, no object with mass can ever reach or exceed it. As something approaches that speed, its energy requirement increases without limit, climbing toward infinity. This is not a rule we can bend or break with better technology, it is woven into the structure of space and time. Even a ship that could somehow travel at 99% of light speed would still take over 4 years to reach the nearest star. At that speed, Earth's solar system would shrink behind it like a fading memory, and still the traveler would see nothing change for a long, long time. The silence between stars is not empty, it is filled with distance too large for any engine we can build. There is a strange beauty in this restraint. The universe could have been built differently, it could have allowed instant travel, effortless speed, but it did not. Instead, it asks us to move slowly, to measure our curiosity against our patience. This slowness gives meaning to discovery. Because travel is difficult, each step outward feels profound. Each new world we reach becomes not just another place, but a symbol of how far we have come. The limits of distance remind us that exploration is not only about movement, it is about perspective. Sometimes, simply understanding the distance is as important as crossing it. Even our greatest achievements in exploration have been modest steps on a cosmic scale. The Voyager spacecraft, launched in the late 1970s, are now the most distant human-made objects in existence. They are more than 14 billion miles from Earth, traveling at about 38,000 miles per hour, and still they have only just crossed the edge of the Sun's influence. At their current speed, they would need more than 70,000 years to reach another star. And yet, even this journey is enough to remind us how extraordinary motion through space can be. A small probe, built by human hands, now drifts in the space between stars, carrying with it a record of who we are, a quiet, steady ambassador of curiosity. As we learn more about how the universe expands, another kind of limitation becomes clear. Space itself is stretching, slowly increasing the distance between galaxies. This expansion means that some parts of the universe are moving away from us faster than light, not because they are breaking any rule, but because space itself is growing between us. Those regions can never be reached, no matter how fast we travel or how long we wait. They will drift beyond our ability to see or touch, becoming permanently hidden beyond the cosmic horizon. This reality is not something to fear. It is simply a reminder that our universe has boundaries, not physical walls but limits written in time and light. Gravity and inertia are partners in this cosmic dance. Everything that moves must also slow, everything that falls must find balance. A spacecraft leaving Earth must push against the planet's pull, but once in motion, it drifts forever unless something stops it. There is no friction in the vacuum of space, no air to press against, no ground to rest upon. Motion becomes endless and stopping becomes the challenge. This is why we plan our journeys so carefully, using the gravity of planets as slingshots to save energy, letting nature assist where power alone would not be enough. Even in the emptiness of space, there are ways to move wisely rather than quickly. Distance is also a limit of communication. When a spacecraft moves far from Earth, the time it takes for its signals to reach us grows longer. The radio waves that connect us to Voyager take over 20 hours to cross the distance between it and our planet. When we send a message to Mars, it can take anywhere from 5 to 20 minutes to arrive, depending on where the planets are in their orbits. This delay means that control must give way to trust. The further we go, the more a machine, or someday a crew, must think and act for itself. Space teaches us that distance is not only a physical gap but a challenge of patience, of silence, of independence. The emptiness itself is another kind of barrier. Space is not completely empty, but its particles are so rarefied that a single cubic foot might contain only a few atoms. There is nothing to breathe, nothing to carry sound, nothing to hold heat. A spacecraft must bring everything it needs, air, warmth, protection, and still, the cold of the universe presses in from all sides. This vacuum cannot be filled or changed. It simply exists, indifferent to whether we travel through it or not. The silence of space is not the absence of sound, it is the presence of stillness. That stillness is both the limit and the beauty of the universe. Even light, which seems to connect everything, fades with distance. A flashlight shining across a room can illuminate the walls, but across billions of miles, that same beam would vanish into darkness. Every star we see is bright enough to pierce that distance, but most of them still dim into invisibility long before their light reaches us. In this way, the cosmos hides itself behind its own laws. We can see only a small part of what exists, a narrow window into an infinite sea. The rest lies beyond our instruments, beyond our reach, waiting quietly in the dark. The reality of these limits does not make the universe smaller, it makes it more real. Knowing that we cannot cross the stars easily makes the stars themselves feel more precious. Knowing that space is vast makes every small step, every distant probe, every new discovery a victory of patience and understanding. The limits are not walls, they are the shape of the story we live in. They define the pace of our progress, the rhythm of our exploration. The universe moves slowly, and in learning to move with it, we find our own kind of harmony. Even as we dream of faster ways to travel, new engines, new physics, new forms of propulsion, we remain bound to the same basic truths. Motion requires energy, distance requires time, and space itself cannot be hurried. Perhaps one day we will find ways to move between stars more quickly, but even then, the distances will still humble us. The universe will always be vast enough to remind us of scale, of proportion, of patience. And that reminder, quiet and constant, is part of its beauty. Slowly, as we understand these physical limits, we begin to accept them not as obstacles but as invitations to wonder. The silence between the stars is not something to conquer, it is something to listen to. The time it takes for light to reach us is not a delay but a gift, allowing us to see the universe as it once was, to witness the history of creation unfolding before us. The challenge of distance, the slowness of speed, the weight of gravity, these are not barriers but teachers. They show us that exploration is not about escape, but about connection, patience, and perspective. And so, the story continues, carried forward by the quiet understanding that every journey begins with limitation. Before we can dream of reaching the stars, we must first accept the distance that separates us. Before we can move faster, we must understand why speed is rare. The limits of physics do not close the universe to us. They open it in a deeper, more meaningful way. They remind us that even in a universe too large to cross, we can still reach with our minds, with our questions, with our awe. And in that reaching, slowly and quietly, we begin to travel. Every journey through space begins with a question of energy. It is the quiet foundation of all motion, the unseen current that allows a spacecraft to rise from the ground, to cross the thin air of our atmosphere, and to drift among the stars. Without energy there can be no movement, no light, no sound, no life. Everything that exists in the universe, from the burning of a star to the beating of a human heart, depends on how energy flows, how it transforms from one form into another. And in space, where there is no air to push against and no ground to rest upon, that flow becomes both precious and fragile. Every bit of motion must be earned, and every ounce of fuel must be carried carefully, guarded like treasure. On Earth, we often take energy for granted. We switch on a light, start an engine, heat our homes, and rarely think about the invisible dance of atoms that makes it possible. But in space, nothing is wasted and nothing is simple. There are no gas stations between planets, no power lines stretched across the void, no atmosphere to burn oxygen. A spacecraft must bring everything it needs for its entire journey: the fuel to move, the power to communicate, the energy to stay warm, and the balance to survive. This makes energy not only a source of motion but also a measure of endurance. To run out of it is not like running out of gas on a quiet road, it is to become silent forever, drifting in darkness, frozen in motion. Every rocket, every probe, every satellite we have ever sent into space carries within it a small story of energy. The story begins on the launch pad, where fire and sound merge into a single force powerful enough to lift metal against the pull of gravity. The chemical energy stored in fuel is released in a flash of transformation. Liquid becomes gas, pressure becomes motion, and for a brief moment, the Earth lets go. The engines burn bright, but the fuel burns fast, and when it is gone, only momentum remains. In that moment, a spacecraft begins its long conversation with emptiness, coasting through space on the power it carried from its birth. Every pound of fuel burned is a pound that no longer weighs it down. Every second of thrust is a second closer to stillness. The balance between energy and mass is one of the oldest and most unforgiving truths in physics. To move faster, you must carry more fuel, but the more fuel you carry, the heavier you become, and the harder it is to move. This endless loop defines the limits of how far and how fast we can go. Even the most efficient rockets spend most of their weight on fuel alone, leaving only a small fraction for instruments, supplies, or people. The ratio is stark but beautiful in its simplicity. Power comes at a cost, and the cost must be paid in full before you leave the ground. This law is not a punishment, it is a reminder of balance, a whisper from nature that every act of motion must be matched by an act of release. Energy exists in many forms: chemical, electrical, nuclear, solar, and each carries its own promise and its own challenge. Chemical fuels, the kind used in most rockets, release enormous amounts of energy quickly, enough to overcome gravity and escape Earth's pull. But they run out fast, and once a spacecraft is in the cold of space, those engines cannot be refueled. Solar energy, gathered by wide panels that unfold like wings, can last for decades as long as sunlight touches them. Yet sunlight fades as distance grows until beyond Jupiter, the rays are too weak to power even a single light. Nuclear energy, drawn from the slow decay of radioactive materials, provides steady warmth and power for missions that travel far from the sun. It burns silently without flame, a small ember that can keep a probe alive in the endless night. Every type of energy has its place, and every mission is a careful compromise between power, time, and weight. The Voyager probes, for example, carry nuclear generators that convert heat into electricity, allowing them to send faint signals across billions of miles. The International Space Station, closer to home, uses broad solar arrays that rotate to follow the sun's path across the sky, collecting energy for lights, computers, and life support systems. Even tiny satellites the size of a shoebox rely on these same principles, balancing panels, batteries, and sensors in delicate harmony. No matter how advanced our technology becomes, the same quiet truth remains. Energy cannot be created from nothing, and every what must come from somewhere. The deeper we travel into space, the more carefully we must think about fuel. A spacecraft cannot carry enough chemical energy to reach the stars. The mass required would be beyond anything we could build or launch. So we begin to look for other ways to move, ways that do not rely on burning fuel, but on exchanging momentum with the universe itself. Solar sails, for example, use the pressure of sunlight to push a spacecraft forward, like wind filling a sail at sea. The push is gentle, almost invisible, but in the vacuum of space where there is no resistance, that tiny pressure can build over time, accelerating a craft silently for years. It is slow, but it is endless, a whisper of motion carried by light. Electric propulsion, or ion engines, offers another path. These systems use electricity, often from solar panels, to accelerate ions to extremely high speeds, creating a steady, delicate thrust. The push is small, barely enough to lift a sheet of paper on Earth, but it continues for months or years without stopping. Over time, that steady push can move a spacecraft faster than any short burst of chemical fuel. The deep, patient rhythm of ion propulsion mirrors the rhythm of the cosmos itself, slow, quiet, and steady, trading power for persistence. Such engines remind us that sometimes the gentlest motion is the most enduring. But even with all our creativity, energy in space remains precious, and waste is unforgiving. Every electrical circuit, every heater, every antenna uses power, and power means heat. On Earth, heat escapes easily through air and water, spreading out until it disappears. In space, there is no air, no breeze, no current to carry warmth away. Heat must be radiated directly into the void, sent outward as invisible light. To keep a spacecraft alive, engineers must design systems that balance temperature like a heartbeat. Never too cold, never too hot. Too much heat and electronics fail. Too little and fuel lines freeze. Even in silence, the struggle for equilibrium never ends. You can think of a spacecraft as a kind of small world unto itself, with its own miniature climate. Inside, energy is always moving, transforming from one form to another. Solar power becomes electricity, electricity becomes motion, motion becomes heat, and that heat must be released again into space. It is a closed cycle, carefully managed by thin layers of metal and insulation. Every watt of power is measured, every source of warmth controlled. In such a delicate balance, energy becomes not only a physical necessity but a kind of philosophy, a reminder that survival, even for machines, depends on restraint and precision. Nothing can be wasted and nothing can last without care. If we ever hope to travel beyond the edge of our solar system, energy will define what is possible. The stars may feel close when we look at them, but they lie across distances so vast that even a small increase in speed demands enormous energy. To reach another star in a single lifetime would require engines that release more energy than humanity has ever produced at once. Some scientists imagine using fusion, the same process that powers the sun, compressing atoms until they release the deep energy locked within. Others imagine capturing antimatter, where a single collision between a particle and its mirror image produces pure light. These ideas are bold and they remain out of reach for now. But they remind us that energy is not only a tool, it is the key to every dream of motion we have ever held. In the meantime, we learn patience. We send probes that move slowly, carried by orbits and gravity, letting the planets themselves assist with motion. We use gravity assists, careful flybys that steal a small fraction of a planet's speed to send a spacecraft farther outward. It is a quiet partnership with nature, using what already exists instead of forcing our way forward. The planets have been circling for billions of years, and they share their motion freely with those who ask gently enough. This way of travel teaches humility. It shows that progress in space is not always about power, but about understanding balance, rhythm, and timing. Even our sun, the greatest source of energy we know, reminds us of this balance. Every second, it releases more power than humanity could use in a million years, and yet most of that light travels outward untouched into the emptiness of space. Only a tiny fraction reaches Earth, and from that small fraction comes every storm, every forest, every living thing. The sun's energy is steady, patient, and vast beyond imagination. It does not rush, it simply shines, converting hydrogen to helium in a process that will last for billions more years. Its quiet endurance is the model of every energy system we have ever tried to build, sustained, continuous, and balanced. When we build our machines, we are really learning from that example. We gather light with solar panels, store it in batteries, and use it sparingly, always aware that what we have is finite. The balance between power and stillness becomes a form of wisdom. The spacecraft that uses too much energy will burn out. The one that uses too little will freeze. Between those two extremes lies the narrow path of harmony, where systems breathe in rhythm with the environment around them. Energy, in this sense, becomes not just a physical resource but a teacher of patience and restraint. The farther we travel, the colder it becomes, and the harder it is to find light. Beyond Jupiter, the sun is a small white star, and its warmth barely touches the frozen moons and drifting debris that circle in darkness. To explore such regions, we rely on stored energy, decaying isotopes that give off heat, turned carefully into electricity by silent converters. The warmth of those systems is not bright, but it is constant, a small flame that never goes out. It is a reminder that even in the coldest parts of the universe, energy is still present, waiting to be transformed, waiting to be used with care. A single watt, well managed, can keep a spacecraft alive for decades. Waste heat, though invisible, is as real as any engine flame. Every electronic device, every signal sent back to Earth, every bit of data processed, adds warmth to the closed system of a spacecraft. Engineers design radiators, flat panels that glow faintly in infrared light, to release that excess energy into the void. There is something poetic about this process. A machine releasing its breath into space, cooling itself by shining, staying alive by glowing softly in darkness. In this way, even heat becomes part of the dialogue between technology and the universe. Nothing is truly wasted, everything is part of the cycle. To understand energy in space is to understand fragility. There are no second chances, no natural refills. Every drop of fuel, every flash of power, every beam of light must be used wisely. Yet within these limits lies beauty. The silence of space makes every spark matter. The darkness makes every reflection precious. When we see the faint light of a distant probe shining far from home, we are witnessing the story of energy transformed, chemical to motion, motion to heat, heat to signal, and signal to knowledge. It is a story written not in words but in physics, in patience, and in the quiet endurance of design. And slowly, as we think about these balances, between power and weight, light and dark, motion and stillness, we begin to see energy not as a struggle but as a partnership. It is the language through which we speak to the universe, the exchange that allows us to move, to see, to know. Every flame, every photon, every heartbeat participates in that same dialogue. The laws of physics are not harsh. They are consistent, guiding us toward understanding rather than speed. In their steadiness we find reassurance. In their limits we find meaning. The story of energy is, in the end, the story of life itself. The same power that drives the stars drives the cells of our bodies. The same transformations that light a rocket flame also light a sunrise. Energy connects everything, the smallest atom to the largest galaxy, and reminds us that motion is never lost, only changed. We live in a universe that conserves, that balances, that waits. And in that patient balance we find our place. The next challenge will be to protect that balance when life itself depends on it, to keep air and water and food in motion, recycling endlessly across the long quiet years of spaceflight. But for now, in this moment, we can rest in the knowledge that energy, though finite, is enough. To live in space is to bring a small piece of Earth along with you. Every breath, every sip of water, every heartbeat depends on an invisible balance that the universe itself does not naturally provide. The void between the planets is silent, cold, and airless. It holds no oxygen to breathe, no liquid water to drink, no soil to grow food. To survive there, we must create a bubble of our own making, a thin shell of warmth and pressure that travels wherever we go. This bubble is fragile, but it holds the essence of everything familiar: air, water, light, and the quiet rhythm of life that connects us back to home. Inside a spacecraft or a space station, life continues in delicate repetition. Machines hum softly, circulating air, filtering carbon dioxide, keeping temperature and moisture in balance. Lights mimic the glow of day and fade to darkness at night, reminding the body when to rest. Every surface, every sound, every vibration has a purpose. What seems like stillness is, in truth, constant motion. Gases being moved, water being recycled, waste being broken down and transformed. The air that fills a capsule may have passed through the lungs of every person on board countless times, cleaned and renewed by systems that never stop running. In that steady rhythm, technology becomes the atmosphere itself. Air on Earth surrounds us without effort. We breathe without thought, and the planet provides endlessly. In space, each breath is a small act of engineering. Oxygen must be created, stored, and replenished. Carbon dioxide, which would build up and poison the air, must be removed or converted. Early missions carried tanks of oxygen, enough for days or weeks, but longer journeys require recycling, the ability to turn what we exhale back into what we can breathe again. On the International Space Station, this process is nearly complete. Machines split water into hydrogen and oxygen, using the oxygen for air and venting the hydrogen away. Other systems draw carbon dioxide from the cabin and convert it into water or other compounds. The result is a closed circle, an artificial atmosphere that mimics the Earth's own. Water, too, must be treated with care. There are no rivers or clouds in space, no rain to refill what is lost. Every drop that enters a spacecraft stays there, moving through the same slow cycle again and again. Water used for drinking, washing, and cooling is collected, filtered, and purified until it is clear once more. Even the moisture from a breath or a bead of sweat becomes part of the system, captured by condensation, cleaned, and returned. This process might sound sterile, but it is the quiet foundation of survival. On Earth, the water we drink has been part of countless cycles across millions of years. In space, that same truth simply becomes more visible. Nothing is wasted, and nothing can be taken for granted. Food in space carries not only energy but comfort. It reminds astronauts of life on Earth, of families and meals shared beneath gravity's steady pull. But growing food beyond the planet presents new challenges. Without soil and sunlight, plants must be nurtured under controlled light, with water delivered through careful systems of mist or hydroponics. Every seed that sprouts aboard a spacecraft is a small promise, a living link between worlds. The first experiments have shown that lettuce, wheat, and even small flowers can grow in microgravity, their roots spreading in all directions, their leaves turning toward artificial suns. These plants do more than feed. They clean the air, renew oxygen, and provide a gentle sense of connection. They remind travelers that life, even in space, can adapt. Energy sustains these systems, but reliability defines them. In space, failure is not an event, it is an end. The systems that create air and water must work without pause for months or years, sometimes for decades. Engineers design them with redundancy, meaning every vital function is backed by another, waiting silently until it is needed. Pumps, filters, and valves are checked again and again, their parts designed to endure countless cycles. Astronauts train to repair and maintain them as if caring for a living being. The hum of these systems becomes the heartbeat of the ship, a sound so constant that its absence would bring instant attention and the temperature inside a spacecraft must also be carefully controlled. Outside, the universe offers extremes beyond imagination. Sunlight that can heat metal to hundreds of degrees, and shadows that drop instantly to freezing cold. There is no air to carry warmth evenly, so heat builds where light strikes and vanishes where it does not. Radiators and heaters work together in perfect balance, releasing warmth when it is too much, preserving it when it is too little. The insulation around a spacecraft is not just protection from impact. It is a kind of skin, keeping the internal world separate from the vast indifference outside. Within that protected layer, human life continues as if the rest of the universe has stepped away to give it space to breathe. Gravity, something so natural on Earth, becomes another challenge in space. Without it, the body begins to change. Muscles weaken, bones lose density, and fluids drift toward the head. To stay healthy, astronauts must create an imitation of gravity through motion, exercising for hours each day, pushing against machines that resist their strength. The effort is not only physical, it is psychological, a routine that keeps the mind anchored in the absence of weight. Life support is not only about air and water, it is about rhythm and familiarity. The sense of a day passing, of effort and rest, keeps the human spirit balanced. Even far from home, the body remembers the gravity it once knew, and the mind follows that memory like a compass. As missions grow longer, these systems must become more like ecosystems, able to function without constant resupply from Earth. Scientists study closed environments, where plants, bacteria, and machines work together to recycle everything. The air we breathe becomes food for plants. The plants return oxygen. Waste becomes nutrients again. It is a cycle that mirrors the Earth's own balance, simplified and contained. To live for decades in space, humans will need to recreate this balance completely, to build small worlds that can survive on their own, carrying all the ingredients of life in endless renewal. It is both a scientific challenge and a moral one. Learning how to live within limits, how to sustain without excess, how to see interdependence as strength. Even small details of daily life become acts of design. A drink of water, a breath of air, a night's sleep, all require systems that work perfectly in harmony. The air pressure must match what the body expects, the humidity must stay within narrow bounds, and even the smallest leak must be found and sealed. Waste management, so simple on Earth, becomes a constant task in space. Every bit of waste must be stored, treated, or reused. Nothing disappears, everything is transformed. The longer a journey lasts, the more these cycles must imitate nature's patience, turning the smallest byproduct back into something useful. The human body is part of that circle, and its needs set the rhythm for every design decision. Over time, the line between human and machine begins to blur. The spacecraft does not merely carry its passengers, it breathes with them, moves with them, responds to their needs. The walls that separate inside from outside become part of the body's own sense of self, like a second skin. This relationship is not mechanical, it is intimate. Each sound, each vibration, each flicker of a monitor tells a story about how the system is feeling. Astronauts learn to recognize these signs instinctively, to listen to their ship as one might listen to the wind. It becomes not a vessel but a companion, a partner in survival. Together, human and machine create a fragile, beautiful balance that holds life in the middle of emptiness. In this way, life support becomes more than technology, it becomes philosophy. It reminds us that existence is always a cycle, a closed system of exchange and renewal. On Earth, we rarely notice this because the planet itself does the work for us. Trees turn carbon dioxide into oxygen, rivers carry away waste, and sunlight renews everything. In space, we must take responsibility for those processes ourselves. We must become caretakers of our own miniature planet, tending every element with care. To sustain life among the stars is to accept the truth that nothing stands alone, that every breath depends on something else. It is a lesson in humility, a slow awakening to the idea that survival and respect are the same thing. When we imagine future journeys beyond the solar system, the question of life support becomes the center of every plan. The distances are so vast that no resupply ship could ever reach them. Generations might live and die aboard a single vessel, relying entirely on closed systems that must last for centuries. The recycling of air, water, and nutrients would have to be complete, precise, and enduring beyond any current technology. These ships would not just be vehicles, they would be ecosystems, moving worlds carrying their own balanced environments through the silence of space. Every life inside would depend on the perfect cooperation of countless small processes, each one invisible yet essential. Reliability in such a journey is more important than speed. The systems must never fail, not for an hour, not for a decade. Redundancy becomes a form of comfort, knowing that there is always another system waiting quietly, ready to take over if needed. This kind of dependability requires more than machinery, it requires a mindset, a culture of maintenance and awareness. Life support is not something that can be turned on and forgotten. It must be lived with, cared for, understood. It is a daily partnership between human vigilance and mechanical precision. And in that partnership, a quiet respect forms. A respect for the fragile line that separates breath from silence. Even with perfect systems, human survival in space depends on more than oxygen and water. It depends on light, on rhythm, on the sense of connection that keeps the spirit calm. Astronauts often describe how the sight of Earth, floating in darkness, gives them strength. The blue and white sphere reminding them of everything they protect and belong to. As we move farther away beyond the reach of sight, we will need to carry that feeling with us. Life support will have to include not only physical needs but emotional ones. Cycles of light and dark to mark time, moments of quiet to restore peace, symbols of home to remind travelers why they endure the vast silence. In that way, even the design of comfort becomes a form of engineering. There is a strange beauty in the idea that to live in space is to live within limits. On Earth, we often forget how much we depend on balance, how easily we consume without noticing. In space there is no forgetting. The limits are constant, visible, and immediate. Every drop of water has weight, every breath has value, every spark of energy has purpose. To survive is to learn mindfulness, to live deliberately, with awareness of what is given and what must be returned. The boundaries of a spacecraft become a mirror for the boundaries of the planet itself, showing us that our world, too, is a closed system, fragile and finite, depending on cycles that must never be broken. Slowly, as we imagine this, we begin to see that the challenge of life support is not about conquering space but about learning from it. It teaches us how to live with care, how to create balance where none exists naturally, how to value what sustains us. Each system, each breath, each drop of water is a reflection of Earth's own generosity, distilled into machinery and design. In caring for those systems, we learn to care for ourselves, and for the planet that taught us what life could be. The promise of exploration, then, is not escape, it is understanding. To carry life into the stars is to carry responsibility with it. And so, in the stillness of a spacecraft drifting between worlds, surrounded by darkness and silence, life continues in quiet cycles. Air is renewed, water is cleansed, warmth is shared, and energy flows in endless circles. The people aboard may be far from home, but they live within a small living world of their own making. Each breath they take is proof of cooperation between nature and design, between human need and universal law. The hum of the systems becomes the sound of survival, the music of persistence. And as they rest, surrounded by this delicate balance, they are reminded that even in the coldest reaches of space, life can endure, so long as we remember how to protect it, how to sustain it, how to honor the fragile rhythm that keeps us alive. Beyond the shelter of Earth's atmosphere, space is not only quiet and cold, it is alive with invisible motion. Streams of particles travel through the void, each one carrying energy from events that happened long before our planet even formed. These particles, though too small to see, move at incredible speeds, crossing billions of miles as easily as wind crosses a field. On Earth, we are protected by a shield of air and magnetism that bends and softens their force. But out in deep space that protection fades. There, radiation becomes a constant presence, silent but powerful, filling the emptiness with energy that never sleeps. The word radiation often sounds frightening, but in truth, it is simply energy in motion. It is light, heat, and charged particles moving through space. Some forms, like sunlight, are familiar and gentle. Others, like cosmic rays or high-energy protons from solar storms, are much stronger, carrying enough power to pass through metal, skin, and bone. On Earth, the atmosphere absorbs most of these rays before they reach us. The few that do arrive are softened by the magnetic field that surrounds our planet, curving them away before they can cause harm. Without this protection, life as we know it would not exist. The air above us and the magnetic field below work together as an invisible blanket, one that we rarely notice but always need. When astronauts travel beyond that shield, they step into a world where radiation flows freely. The International Space Station still moves within the upper edge of Earth's magnetic field, so its crew receives more exposure than on the surface, but far less than they would in deep space. Once we go beyond the reach of that field, past the Moon, past Mars, into interplanetary space, the rules change completely. Here, the constant rain of high-energy particles becomes a challenge that cannot be ignored. Each particle is small, but when billions of them pass through a spacecraft every second, their effect adds up over time. Radiation is not felt as heat or light. It is silent, invisible, and persistent. Cosmic rays are among the most energetic travelers in existence. They are mostly protons, born from the explosions of distant stars, traveling near the speed of light. Some come from supernovae, cataclysmic events where stars end their lives in bright, violent bursts. Others come from even more distant galaxies, flung outward by forces we can barely understand. When these particles strike a spacecraft or a human body, they collide with atoms, creating secondary showers of energy that can disrupt electronics or damage cells. Over time, exposure increases the risk of illness and genetic change. The challenge is not to avoid cosmic rays, they are everywhere, but to manage their presence with understanding and care. Closer to home, our own sun also sends waves of radiation across the solar system. Most of the time, this radiation arrives as a gentle flow of charged particles called the solar wind. It spreads outward in all directions, shaping a vast bubble around the sun known as the heliosphere. Within that bubble, the solar wind creates a kind of boundary between our system and the interstellar medium beyond. But sometimes, the sun releases massive bursts of energy known as solar flares or coronal mass ejections. These events can send waves of high-energy particles racing outward, reaching planets and spacecraft in hours. When such storms occur, they can disrupt satellites, interfere with communication, and endanger astronauts caught outside of protective shelters. To live or travel in space, we must therefore build our own forms of shielding. On Earth, our air and magnetism perform that duty naturally, but in space we rely on materials and design. Aluminum, water, and specialized plastics can absorb or scatter some of the radiation that passes through. Yet every layer of shielding adds mass, and in spacecraft design, mass is always a precious resource. Too much shielding and the craft becomes too heavy to launch, too little and the crew is exposed. Engineers must find balance, building protection that is light yet strong, complete yet flexible. The trade-off between safety and efficiency becomes an art, one shaped by physics as much as imagination. Water is one of the most effective materials for absorbing radiation, which makes it both useful and symbolic. In some designs, tanks of water are placed around living quarters to serve as natural shields. In others, wastewater is stored in outer layers for the same reason. Some future concepts even imagine using fuel or food supplies as barriers, turning every part of a ship into part of its defense. The idea is simple but profound. In space, nothing is separate and everything has a purpose. Protection, motion, and survival all merge into one design, each element serving more than one need. Every drop of water, every ounce of material becomes part of a system that protects life from the invisible tides of energy beyond. Even with shielding, radiation remains a part of the environment, just as weather is part of life on Earth. It fluctuates with the sun's cycles, growing stronger and weaker in rhythm with magnetic storms that occur roughly every 11 years. During quiet periods, the flow is gentle. During active times, it can increase dramatically. Spacecraft must be built to withstand these changes, with instruments that monitor the radiation levels and systems that adjust operations as needed. When a strong solar event occurs, astronauts might retreat to areas of thicker shielding, waiting until the wave passes. These precautions are not acts of fear but of respect. For the sun, for nature, for the quiet power that sustains and challenges us at once. The body itself reacts to radiation in ways that are complex and subtle. Cells are designed to repair themselves, to replace what is damaged, to heal what is broken. But when radiation exposure is constant, that repair becomes a struggle. The effects may not appear immediately, they may take years to develop. In the short term, high doses can cause sickness, fatigue, or confusion. Over longer periods, exposure can alter DNA or increase the risk of illness. This is why future journeys to Mars or beyond must consider not only propulsion and energy but also biology. The human body is both strong and delicate, resilient but not invincible. It can endure much, but it cannot ignore the steady, invisible touch of cosmic energy. Electronic systems face similar risks. High-energy particles can pass through circuits and cause brief, random errors known as bit flips. A single stray particle can change a 0 to a 1, altering data or commands. For most modern spacecraft, these errors are expected and managed through redundancy and error correction. But as missions last longer, even small disruptions can build over time. Designing machines that can endure radiation is like teaching them patience. The ability to continue working through constant, quiet interference. The Voyager probes, now far beyond the Sun's protection, still send messages across the stars, proof that careful engineering can endure even in the harshest environment. As we move farther into the galaxy, we will face new forms of radiation from regions beyond the heliosphere. In interstellar space, the Sun's protective bubble ends, and the density of cosmic rays increases. This region is not empty but filled with particles drifting between the stars, atoms stripped of electrons, remnants of long-vanished suns. Each one moves independently, yet together they form a kind of invisible ocean. Spacecraft traveling through this ocean must be built to withstand constant impact, not of solid objects but of energy itself. Every second, trillions of microscopic collisions occur, each too small to see but too persistent to ignore. The journey beyond our solar system is, in many ways, a journey through this unseen storm. Understanding radiation means accepting that it is not an enemy but a natural part of the universe. The same energy that threatens life also creates it. Cosmic rays help form new atoms, trigger chemical changes, and even play a role in the birth of stars. On Earth, radiation from space has always reached the upper layers of the atmosphere, where it interacts with molecules to create light and particles that fall like a faint, constant rain. Some of these interactions may have helped spark the first complex chemistry of life itself. In this sense, radiation is not only a challenge to be solved, it is a reminder of connection, a thread that ties us to the universe's most ancient events. In designing ways to protect ourselves, we are also learning to live in balance with what surrounds us. Radiation teaches humility. It cannot be stopped entirely, it can only be managed, respected, understood. Each mission that leaves Earth becomes an experiment in that understanding, a test of how well we can live within the universe's natural limits. The knowledge we gain does not belong only to space travel, it belongs to life itself. The Earth's own magnetic field, for example, may shift and change over time, reminding us that even our home is not fixed in protection. Learning how to endure radiation teaches us how to appreciate the invisible shields that have always kept us safe. The trade-off between shielding and weight remains one of the greatest puzzles of deep space travel. Every additional layer of protection costs energy to launch, yet every omission increases risk. Some researchers imagine ships built from magnetic fields themselves, artificial bubbles that could deflect charged particles the way Earth's magnetosphere does. Others dream of new materials that absorb radiation more efficiently, or biological methods that could help the body repair itself more effectively. These ideas, though distant, all point toward the same truth. Survival in space will not come from resistance alone, but from harmony, from learning to adapt to the universe rather than trying to escape it. Every time we send a probe, a rover, or a person beyond Earth, we test our relationship with radiation anew. The data collected by instruments in orbit or by sensors on the surface of Mars tells us not only about danger but about beauty. The auroras that dance near the poles of our planet are born from solar particles striking the upper atmosphere, turning invisible energy into waves of light. The same process that threatens spacecraft also paints our skies with color. There is balance in everything if we choose to see it. What harms can also illuminate, what challenges can also inspire. As you picture a spacecraft traveling through this invisible storm, imagine it moving slowly, wrapped in thin layers of protection, surrounded by silence. Each tiny particle that touches it is a story from the past, a memory from a star that lived and died millions of years ago. The ship does not resist them all. It accepts what it must, deflects what it can, and continues forward. In that steady motion, there is something deeply human, the willingness to endure, to adapt, to keep going even when the forces of nature cannot be controlled. Radiation becomes not a wall but a teacher, showing us what it means to live with awareness, to exist within the flow of energy that fills the universe. And as we learn to travel farther, this understanding will shape the way we think about safety, design, and even home itself. We will know that protection is not the same as isolation, that true endurance means balance, not defiance. The universe is not hostile, it is vast and it operates by laws that ask for respect. Radiation is one of those laws, a reminder that, in the end, the presence of radiation is not something to fear. It is simply another part of the universe's quiet conversation with itself, another reminder of how energy and matter exchange stories across time and distance. The light that warms your face on Earth, the glow that feeds a solar panel, and the cosmic rays that drift through the galaxy are all expressions of the same fundamental truth. Everything is connected through energy. The challenge of radiation is the challenge of life itself, to endure, to adapt, and to keep shining even in the presence of constant change. Slowly, through understanding, we learn not to hide from that energy but to move with it, gracefully, patiently, endlessly. Time, like distance, is one of those things we think we understand until we begin to measure it beyond our ordinary lives. On Earth it feels simple. The sun rises and sets, days turn into weeks, weeks into years. We wear time around us like an invisible current, always moving forward at the same steady pace. But in space that rhythm begins to change. Time itself stretches and bends, responding not to our clocks but to gravity, speed, and the very fabric of the universe. It is still time, but it moves differently, quietly reminding us that our experience of it is only one version among many. The theory of relativity, discovered more than a century ago, tells us that time and space are not separate things but parts of the same woven fabric. When something moves very fast or passes near a strong gravitational field, that fabric stretches, and time flows more slowly for the traveler than for the one who stays behind. On Earth, this difference is so small we never notice it. But in the vastness of space, where speeds approach the limit of light, or gravity becomes extreme near stars or black holes, those differences can grow until they become years, decades, or even centuries. Time, in this sense, is flexible, not in the way of imagination but in the quiet, measured way of physics. For the astronauts orbiting Earth, this effect is real, though subtle. Their clocks tick a little slower than ours by fractions of a second each year. When they return, they are slightly younger than those who remained on the ground, though the difference is so small it can only be measured by instruments. Still, the effect exists, a gentle whisper of the deeper truth that time is not fixed. It bends and stretches like the surface of a calm lake touched by wind. When we think of journeys to other stars, where motion must approach a significant fraction of light speed, this bending of time becomes something much more profound. A traveler could leave Earth and return to find that centuries have passed while only a few years have gone by for them. Imagine a spacecraft moving at such incredible speed, crossing the empty reaches between stars. To those aboard, time would seem to flow as always, seconds, minutes, and hours moving in their familiar rhythm. But back on Earth, years would be unfolding, history would be changing, generations would be born and gone. The traveler would not feel the slowing of time. It would be invisible, natural, as if nothing unusual were happening. Only when they returned, or tried to send a message home, would the difference reveal itself. This is not science fiction. It is one of the simplest and most certain consequences of relativity. The faster we move through space, the slower we move through time. In this way, distance and time become partners, inseparable and intertwined. To travel across space is also to travel into the future because time flows differently for those in motion. Every step away from home is a step forward in time, every acceleration a deepening of separation. Communication across these distances becomes more than a technical problem. It becomes a challenge of perspective. A message sent from a ship moving near the speed of light would arrive years later, even if the ship seemed only moments away from its cruise point of view. The universe, with perfect calm, enforces patience as one of its laws. Light itself is the messenger that connects us across these immense scales, but even light has limits. Its speed, about 186,000 miles per second, is the fastest that any signal can travel. That sounds immediate, but over the distance between stars, it becomes slow. A message sent to a spacecraft near the edge of our solar system can take hours to arrive. A message to the nearest star system takes over 4 years. There is no way to hurry this exchange. Even the most powerful transmitter cannot overcome the boundary of light speed. In this way, communication becomes a conversation stretched across time, a quiet dialogue between the present and the future. Imagine standing outside your ship, watching the stars drift past in slow silence. To you they seem fixed, unchanging, as if time has paused. Yet, from a different point of view, those same stars are moving rapidly, their light bending around you as space itself adjusts to your motion. This is relativity in its most poetic form, not a trick or illusion but a relationship between all things that move. Each observer carries their own version of time, and every version is correct. There is no universal clock, no single rhythm for the cosmos. The universe flows according to many overlapping currents, each one real, each one connected to the others by light. This idea can feel strange at first because our lives depend on a shared sense of time. We meet, we speak, we measure, we plan. Our society, our memories, our sense of identity, all rest on the assumption that 1 second is the same everywhere. But the deeper we go into the universe, the more that assumption begins to dissolve. Time near a massive planet flows slightly slower than time far from it. A clock on the surface of Jupiter would tick differently than one floating between the stars. Even gravity, which seems like a simple pull, is really a bending of space-time, a gentle curve that slows both motion and duration. The weight of time itself becomes visible through the dance of orbits and light. There is a quiet humility in realizing that time does not belong to us. It is not a human invention but a property of the universe, shaped by energy and motion. We live within it as fish live within water, rarely sensing the medium that surrounds us. To travel through space is to begin to feel that medium. For those who may one day leave Earth for journeys lasting decades or centuries, the relativity of time will become part of daily life. The mission will not only measure distance but also measure change. Families left behind will grow old, cities will evolve, languages may shift. The traveler will carry memories of a world that no longer exists, returning to one that has moved on without them. This thought can seem lonely, but it can also be peaceful. It reminds us that everything changes, that time never stops, that the universe moves forward with or without us. In that truth, there is acceptance, a quiet understanding that to travel far is to let go of the idea of return. The communication delays between distant places are another lesson in patience. When signals take minutes or hours to travel between planets, conversation becomes something slower, more reflective. Instructions cannot be given in real time. They must be planned, trusted, and followed independently. In a way, this delay teaches a new kind of connection, one based not on constant contact but on faith and anticipation. Each message, when it finally arrives, becomes more meaningful because of the time it took to reach its destination. Even silence becomes part of communication, a pause that carries weight and understanding. Relativity also changes the way we think about the future. When we look at distant galaxies, we are seeing them as they were millions or even billions of years ago. The light that reaches us tonight left those galaxies long before the Earth existed. In that sense, our entire view of the universe is a window into the past. The stars we see may already have changed or disappeared, but their light continues its journey toward us, carrying the memory of what once was. Time and light together create a kind of cosmic archive, a record written in brightness and shadow, in color and motion. To look into the sky is to read history written across space. In the same way, to send light outward, radio waves, data, or even the faint glow of a spacecraft, is to leave a trace of our present for the future to find. The signals we send travel endlessly, growing weaker but never stopping. Somewhere billions of miles away, the faint echo of a human heartbeat or a voice may still be crossing the void. It is comforting to think that the universe holds these traces of us, tiny sparks of information drifting through time. Even if they are never received, they exist as part of the ongoing story of light. We are not only living in time, we are leaving our own marks upon it. The slowing and bending of time near massive bodies reveals another layer of the universe's grace. Near a black hole, for instance, gravity is so strong that time slows almost to a stop. An observer watching from a safe distance would see anything near the event horizon moving endlessly slower, never quite disappearing, frozen in time. Yet to the traveler falling inward, nothing unusual would seem to happen. Their experience of time would remain smooth, natural, flowing forward as always. This difference, this contradiction, is the essence of relativity. It shows us that reality is shaped by where we stand, that every point in space has its own clock, its own truth. To understand these truths is not to feel lost, but to feel connected in a new way. Time becomes less like a line and more like a landscape, full of valleys and ridges, slopes and curves. We move through it not as passengers on a single path, but as travelers in a field of motion, our experiences overlapping and diverging in endless ways. The universe, in its vast patience, allows all these versions to exist at once. There is no conflict in this, there is only harmony. Every moment, every second, every heartbeat is part of a single unfolding whole. For the human mind, this can be difficult to grasp because we live in a narrow window of perception. Our lifetimes are short compared to the ages of stars. We measure time by the turning of the earth, by seasons, by memories, but the universe measures differently. It measures by light, by motion, by the slow cooling of stars and the expansion of galaxies. To live among the stars, we must learn to think in that scale, not as an act of arrogance but as an act of awe. Time, once seen as a limitation, becomes a gift, a reminder that even in change there is continuity. As spacecraft move farther from Earth, the experience of time will continue to shape our exploration. Crews will learn to adapt to communication delays, to the slow passage of days without sunrise or sunset, to the awareness that their own time is not the same as the time they left behind. This adjustment will not only be technological, it will be emotional, philosophical, and deeply human. The act of travel will become an act of transformation. Every journey through space is also a journey through the layers of time, each mile carrying us not only farther in distance but deeper into the understanding of what it means to exist. Even now, on Earth, we experience relativity in small and constant ways. Time moves differently for everyone because of experience, memory, and perception. A moment of joy can feel endless. A year can pass in a blink. The physics of relativity only extends that truth to the universe itself. It reminds us that time is not an absolute march but a gentle, variable flow. In space, that flow becomes visible, measurable, undeniable. The clocks on our ships and the clocks in our hearts will not always agree, but both will tell the truth of their own paths. And so, time becomes not an obstacle but a companion. It stretches and bends, but it does not disappear. It waits, it teaches, it connects. To travel through the universe is to learn to move with time rather than against it, to accept its shape and its silence. The stars themselves are time made visible, their light carrying stories from billions of years ago. When we gaze at them, we are not only seeing the past, we are touching the continuity of existence. The future, too, already exists somewhere along that same curve, waiting for us to arrive. When the traveler finally looks back toward home, the light of Earth may reach them from a different age. What they remember may no longer exist, and yet, in the light that travels outward, it will always remain. The universe holds every moment within its structure, each one preserved in the movement of light and gravity. To live in such a universe is to be part of something timeless, something vast and kind. Time does not erase, it transforms. And as we move through it, we become part of that transformation, carrying our small, precious sense of the present through the endless rhythm of change. To travel through space is to move through a realm without landmarks. There are no mountains to guide the way, no oceans or coastlines to measure distance. The stars themselves seem fixed, yet they drift slowly, imperceptibly across the centuries. Every direction looks the same, and every destination is defined by light that left long ago. In this vastness, navigation becomes not a matter of sight but of understanding. It is the art of knowing where you are when the nearest reference point may be billions of miles away, and when even a small error can grow into a gulf so large that correction becomes impossible. On Earth, navigation once depended on the horizon, on the sun's rise and fall, on the pull of the compass toward the magnetic north. Sailors learned to read the stars, to measure angles and shadows, to find their way by light that never seemed to move. In space, that ancient art continues, but in a quieter, more intricate form. Spacecraft navigate by listening rather than looking, listening to signals from Earth, to the rhythm of pulsars, to the faint tug of gravity from nearby worlds. Each motion is calculated, each correction planned with precision that reaches far beyond human instinct. The silence of space demands patience, and patience becomes the compass. Every spacecraft carries a small library of information about where it is and how fast it moves. Gyroscopes sense rotation, star trackers compare their view to maps of known constellations, and radio signals from Earth provide a steady point of reference. From these tiny clues, a computer can determine its position in the solar system with astonishing accuracy. Yet even this precision is fragile. A miscalculation of a fraction of a degree, a single wrong command, or an unnoticed drift can, over time, lead a ship astray. When distances stretch into billions of miles, small errors multiply until they become entire worlds apart. In this way, navigation in space is not about control, it is about humility. Light itself becomes part of the navigation process. The delay between sending a signal and receiving a reply tells us distance. The change in frequency caused by motion tells us speed. By measuring these faint differences, sometimes just the width of a human hair over the length of thousands of miles, engineers can guide a spacecraft with astonishing precision. Yet that same precision reminds us how delicate the process is. Every correction takes time, every command must travel across the emptiness, every action must wait for confirmation. There is no instant response, no quick adjustment. To navigate space is to live within the rhythm of light itself. The Voyager probes, launched more than 40 years ago, continue to teach us what long-term reliability truly means. Their systems, built with the technology of the 1970s, still function in the cold dark between the stars. Their instruments no longer record as much data as before, and their signals have grown faint, but they remain alive, steady, loyal, unhurried. Their trajectories were calculated with such precision that they continue along their paths without need for correction. These small machines, powered by decaying atoms and guided by mathematics, have become a symbol of endurance. They show that reliability in space is not only about power, it is about trust in design, patience, and the quiet persistence of purpose. Every spacecraft must balance between autonomy and connection. The farther it travels, the less it can depend on real-time guidance from Earth. Communication delays stretch from seconds to hours, and decisions must be made without waiting for permission. Navigation becomes a shared responsibility between human and machine, a partnership where trust replaces control. On the surface of Mars, for instance, rovers receive general commands from Earth but must make their own choices about how to move, where to turn, and how to avoid obstacles. They think in small steps, guided by sensors and algorithms that interpret the world around them. This independence is not freedom, it is survival. Reliability in space depends on foresight. Systems must be designed not only for performance but for endurance. Every circuit, every valve, every line of code must be built to last through extremes of temperature, radiation, and time. There can be no easy repairs, no replacement parts, no second chances. Engineers test, retest, and test again, imagining every failure before it happens. In this way, design becomes a form of meditation, an exercise in imagining stillness that lasts forever. The spacecraft that endures is not the one that is strongest, but the one that is simplest, balanced, and forgiving. Complexity can fail, simplicity endures. Over decades, the materials that form a spacecraft begin to change. Metal expands and contracts with temperature, plastics grow brittle, tiny particles of space dust strike with the force of bullets. Even light itself can slowly damage the sensors and circuits that once seemed immortal. Yet, despite all this, many spacecraft continue to function, defying the odds with quiet grace. Their success comes not from perfection but from resilience, the ability to adapt to imperfection, to continue even as parts weaken. This kind of reliability is not mechanical alone, it is philosophical. It mirrors the endurance of life itself, which survives not by avoiding damage but by finding ways to heal and continue. Navigation is not only a technical act, it is a form of mindfulness. To move through space is to be aware of everything, to measure constantly, to adjust gently without haste. The smallest course correction can change a future by millions of miles. Every decision must be made with calm precision, knowing that impatience can lead to loss. The patience of space navigation teaches a lesson about existence itself, that direction matters more than speed, and that steady progress, no matter how slow, can carry you across any distance. The universe moves with the same principle, expanding not in bursts but in quiet persistence. For missions meant to last generations, navigation and reliability become intertwined in ways we are only beginning to imagine. To imagine such endurance is to think beyond human timescales. Machines that last for centuries must be designed like seeds, small, self-sustaining, and capable of surviving long dormancy. They must be able to wake when needed, to repair themselves, to adapt to change. Navigation would not be a single act but a constant awareness, a quiet listening to the universe for guidance. Perhaps they would use the pulses of distant neutron stars as cosmic lighthouses, their signals as steady as the heartbeat of time. The stars, after all, are the most reliable beacons in existence, shining with patience that outlives any human creation. On long journeys, even small uncertainties can grow large. A tiny drift in angle, a small misreading of a signal, can lead a ship to miss its target by millions of miles. For this reason, redundancy is not luxury, it is law. Every system must have a partner, every sensor a twin, every function a backup waiting silently in reserve. The strength of a spacecraft lies not in perfection but in layers of care, each one ready to take over when another fails. This idea extends beyond machines. It reflects how life itself endures. Families, ecosystems, societies, all depend on cooperation, on shared resilience, on the quiet readiness to adapt when change comes. Even with all this care, space remains unpredictable. Dust storms on Mars, magnetic fields near Jupiter, or gravitational tugs from unseen asteroids can alter a path without warning. Navigators plan for uncertainty as much as for precision. They accept that no calculation can ever be perfect, that the universe will always introduce its own variations. This acceptance is not defeat, it is harmony. It means learning to move with the flow of celestial mechanics, to trust in the patterns of orbits and tides of gravity. A well-designed course is not a straight line. It is a curve, adjusted gently over time, always listening to the universe's quiet corrections. Reliability, too, is not static. It is the ability to remain true to purpose while changing with circumstance. A spacecraft that adapts, that conserves energy, that prioritizes what matters most, embodies this kind of intelligence. It is not emotion but wisdom, an understanding that endurance depends on balance. The systems that have survived longest in space, like the Voyagers, share this quiet intelligence. They know when to rest instruments to save power, when to awaken to send a signal home, when to let silence stretch between transmissions. They have learned, in their way, the rhythm of patience. For the humans who depend on these systems, trust becomes a form of faith. A crew deep in space must believe in their ship, just as ancient sailors once believed in their vessels crossing uncharted seas. They must listen to its hum, feel its vibrations, and understand its moods. Every sound, a soft click, a sudden silence, has meaning. This awareness creates a bond between human and machine, built not on control but on cooperation. The spacecraft protects its passengers, and in return they care for it. Together they form a single organism of survival, bound by the same need to endure. When navigation and reliability merge perfectly, they create a kind of serenity. The ship moves not with force but with grace, guided by subtle corrections, steady in its motion. It does not fight the universe, it flows with it, responding to every change with calm adjustment. This is the essence of sustainable travel, not to overpower nature but to become part of its rhythm. A ship that can move this way could travel forever, needing only light and time to continue. Its journey would not be a race but a meditation, a long, slow conversation between creation and persistence. Even now, our most distant probes continue this conversation. Long after their missions officially ended, they still send faint signals back to Earth, whispers of data that cross billions of miles. Each bit of information takes hours to arrive, but it carries within it a story of endurance. Their clocks tick slowly, their power fades, yet their navigation remains steady. They continue not because they are powerful, but because they were built with care, guided by the principle that precision and patience can outlast even time itself. In their quiet persistence, they reflect the best of what we are: curious, patient, enduring. When we think of navigation in this way, it becomes more than a science. It becomes a reflection of existence itself. To navigate is to live, to find direction through uncertainty, to correct gently when we drift, to keep moving toward what we value most. Reliability, in turn, is the art of faithfulness, of staying true even when conditions change. Together they form the foundation of exploration, of survival, of meaning. The universe does not demand perfection from us. It asks only for consistency, for care, for respect of its laws. If we can move through space with that spirit, we will never truly be lost. And so, in the great silence between the stars, the traveler continues. The instruments hum, the systems breathe, and navigation unfolds like a slow heartbeat. Each calculation, each signal, each small correction adds to a tapestry of trust that stretches across light years. Even when no one is watching, the ship continues to move, steady and faithful, carrying within it the essence of our will to know. Reliability becomes memory, navigation becomes hope. Together, they allow us to cross the infinite, not with noise or haste, but with patience, precision, and quiet grace. To live in space is not only a physical journey, it is an inner one. Beyond the comfort of Earth, where the sky and the horizon mark our sense of belonging, there is only endless night and quiet. The stars are beautiful, but they are also distant, and that distance begins to shape the mind in ways that are difficult to imagine. Inside the thin walls of a spacecraft or a station, life continues in slow circles, surrounded by silence so complete that even the smallest sound becomes important. The mind, like the body, must learn to adapt. It must find new rhythms, new forms of comfort, and new meanings for words like home and together. Isolation. Astronauts who spend long periods away from Earth describe a strange duality. They are surrounded by technology, by motion, by the constant awareness of risk, and yet they also feel a deep sense of calm. There is no noise from the outside world, no distractions, no constant flood of information. In that stillness, thoughts slow down. The days begin to blend into one another, marked only by small routines: exercise, meals, communication sessions, and rest. These routines become the framework of sanity, the structure that holds the mind in balance. Without them, the sense of time can drift, and the feeling of purpose can begin to fade like light in deep water. Communication delays make this sense of isolation stronger. A message to Earth may take minutes or hours to arrive, and the reply comes later still. There are no instant answers, no quick reassurances. The voice from home becomes something distant, wrapped in echoes of time. Even a simple conversation turns into a slow exchange of recorded words, more like sending letters than speaking. This delay forces those who travel far to rely on their own thoughts, to become their own source of comfort and motivation. They must learn to be their own companions, to fill silence with reflection rather than fear. Inside a spacecraft, companionship becomes sacred. A crew may consist of only a few people, each one essential to the other's survival. They share everything: air, food, work, and dreams. In such closeness, understanding becomes more important than ever. Small tensions can grow quickly if left unresolved, so patience becomes a form of survival. Each person learns the rhythms of the others, their moods, their silences, their ways of thinking. Friendships deepen, sometimes beyond words, not through constant conversation but through the quiet knowledge that each person depends completely on the others. In that shared dependence, isolation softens, replaced by connection born of trust. The human mind seeks meaning wherever it goes. In the vast emptiness of space, that search becomes even more essential. Without landscapes, weather, or seasons, the mind begins to create its own patterns. Astronauts have described how they find beauty in the smallest details: a reflection on a metal surface, the faint hum of a fan, the play of light across the walls of a cabin. These small observations become symbols of continuity, reminders that life still exists in its many forms. The absence of distraction can heighten awareness, allowing moments of stillness to feel almost sacred. The mind begins to see the universe not as empty, but as peaceful, vast, and alive in its own quiet way. Dreams take on new forms in space. Without the familiar cues of day and night, the body's natural rhythms begin to change. Sleep can come in waves rather than long stretches, and the dreams that appear often mix memories of Earth with the endless view of stars. Some astronauts describe dreaming of gravity, of walking, of feeling the pull of weight beneath their feet. Others dream of water or of wind, sensations that the body remembers even when the mind has moved on. These dreams become a bridge between two worlds, keeping the traveler connected to everything left behind. The lack of physical space also affects the mind in subtle ways. On Earth, we are used to distance, the open sky, the stretch of a horizon, the ability to step outside and feel the wind. In a spacecraft, every wall is close, every corridor narrow. There is no real separation between work and rest, between personal space and shared space. The air is for some, isolation brings a deeper understanding of connection itself. When you are far from everything you know, every memory grows sharper, every image of home more vivid. The small moments, laughter with friends, the sound of rain, the smell of trees, return with new importance. Distance does not erase them, it magnifies them. In this way, space teaches appreciation. It reminds the traveler that the world they left behind is fragile and beautiful, that every detail of life on Earth is part of a vast and delicate harmony. The longing for home becomes not sadness but gratitude. The mind, when it has time and silence, often turns toward wonder. Questions that were drowned out by noise on Earth begin to rise again. Who are we? Where do we belong? What does it mean to be alive in a universe so large and so quiet? These are not questions to be answered quickly, and perhaps they are not meant to be answered at all. They are companions traveling with the crew as surely as any instrument or machine. The search for meaning becomes a form of navigation, a way of orienting the heart when maps and stars are not enough. In the stillness of space, thinking itself becomes an act of survival. Even the smallest rituals help maintain balance. The simple act of sharing a meal, of writing in a journal, of looking out a window at the same familiar star, these become markers of continuity. They remind the traveler that time is still moving, that life continues to unfold. Music, stories, and memories carry a sense of rhythm, filling the silence with gentle echoes of Earth. Over time, these rituals become sacred not because of what they are, but because of what they represent. The persistence of humanity in a place where nothing grows and nothing moves except through the will of those who endure. In the long silence between messages, in the dim glow of artificial light, the mind learns to find comfort in its own thoughts. It begins to slow, to drift, to listen. The heartbeat becomes the clock, the breath becomes the measure of time. The vast distance between stars becomes less frightening, more like an open field waiting to be crossed in imagination. The traveler begins to realize that isolation is not punishment, it is perspective. It offers a view of the universe that few will ever know, a direct experience of existence stripped of distraction and noise. In that simplicity lies peace. And when the journey continues as it always must, the mind carries with it the lessons of solitude. It learns that patience is strength, that stillness can be full of meaning, that silence can hold more beauty than sound. It learns that connection is not always physical. It can live in memory, in purpose, in the shared heartbeat of those who once stood under the same sky. Space does not take these things away, it reveals them more clearly. It shows us what we are when everything else is gone. Small, thoughtful, resilient, and deeply connected to the mystery that surrounds us. There comes a moment, somewhere in the quiet between the stars, when words no longer feel large enough to hold what is seen. The universe stretches in every direction, endless and patient, its light scattered across time like soft music fading into distance. In that stillness, something changes inside the observer. The sense of self begins to blur, to soften, until the line between I and everything grows thin. What remains is a feeling beyond thought, a calm awareness of belonging to something vast, something timeless, something both strange and familiar. It is not fear, not loneliness, but awe, deep and quiet as the breath before sleep. The human mind is small compared to the universe, but it is also capable of wonder, and that ability makes it limitless. We do not need to cross the galaxy to feel connected to it. We only need to look, to listen, to be still long enough for its rhythm to touch our own. Every photon of light that reaches our eyes carries the memory of a journey that began long before we were born. The light of distant stars, the glow of galaxies far beyond sight, all of it speaks in a language older than time itself. To look into that distance is to read a story written in light and gravity, a story that includes us even though we are only one small line within it. When we see images of galaxies taken by the great telescopes, spirals of light turning through blackness, glowing dust where stars are born, it is hard not to feel both small and infinite at once. The shapes are familiar yet impossible, delicate yet eternal. Every curve of a galaxy holds billions of suns, each with worlds that might circle them, each world a mystery of its own. Somewhere, perhaps, there may be oceans, clouds, and winds much like ours. Somewhere, light may fall on living eyes that look up as we do, wondering whether they too are alone. The thought is humbling and beautiful in its uncertainty. The universe does not answer our questions, but it allows us to ask them. In the silence of deep space, the feeling of awe is not loud or dramatic. It arrives slowly, like dawn on a quiet morning, filling the mind with still light. The stars do not shout their presence. They simply are, constant and ancient. When astronauts describe looking back at Earth from orbit, they often say the same thing, that the planet looks fragile, perfect, and impossibly alive. A thin blue line of atmosphere glows against the black, a reminder that all we have and all we are exists within that narrow boundary. The feeling that follows is not pride or power, it is tenderness, a kind of love for the smallness that holds everything we know. To see Earth from far away is to understand connection in a new way. The borders, the divisions, the noise of daily life, all disappear into a single sphere of color. The oceans merge with the sky, the continents glow with the warmth of sunlight, and the thin veil of clouds drifts like breath. Every living thing, every human story, exists together within that single point of light. From space there are no separate nations, no strangers, no distance. There is only home, turning slowly through the dark, wrapped in sunlight and shadow. The image of Earth, hanging in the blackness, is one of the most peaceful sights ever seen by human eyes. Awe is not about power, it is about perspective. It is the moment when understanding meets humility, when knowledge meets silence. Science can explain how stars form, how galaxies spin, how time bends, but awe is what fills the space between those explanations. It is the part of wonder that cannot be measured, only felt. The vastness of the universe does not demand our fear, it invites our respect. To stand beneath the stars, whether on Earth or in orbit, is to feel that invitation. It asks nothing from us but awareness, and in return it gives peace. The stars remind us that creation is continuous. What we call empty space is full of energy, full of particles dancing in patterns too subtle for our eyes. Clouds of gas collapse under gravity, igniting into light that burns for billions of years, and when those stars die, their remnants scatter new elements into the void. Those elements become planets, oceans, and living beings. The iron in our blood, the calcium in our bones, the oxygen we breathe, all were once part of stars that lived and died long before Earth existed. To realize this is to understand that we are not separate from the universe. We are made of it, sustained by it, destined to return to it when our brief moment passes. Even time itself feels different when seen through this lens. The human lifetime, though short, is part of a longer rhythm. Every second we live is part of a chain that stretches back through generations, through species, through the slow rise of continents and the long cooling of stars. The atoms that form our bodies have existed for billions of years, joining and separating countless times in the great cycle of matter. We are the current shape of an ancient process, the latest form of a pattern that will continue long after we are gone. This realization does not diminish us, it completes us. We are temporary, but we are also eternal in the way that all matter is eternal. There is a kind of peace in knowing that nothing is wasted in the universe. Energy changes form, matter transforms, and every end becomes a beginning. A star's death gives birth to new stars. The collapse of one world may one day give rise to another. Even the smallest particles drift with purpose, guided by laws so simple that they hold galaxies together. The same force that draws an apple to the ground holds the moon in orbit and shapes the path of every planet. Gravity, light, and time weave a single fabric that connects everything. The universe is not chaos. It is a quiet order vast enough to contain all things. When we allow ourselves to feel awe, we become part of that order. The mind grows still, the body relaxes, and the heart finds rhythm in the motion of creation. The need to understand gives way to simple appreciation. We see the beauty not only in stars and planets, but in the quiet laws that make them possible. The universe does not need us to notice it, but when we do, something within us aligns. We remember that awareness itself is rare and precious, that the ability to look up, to wonder, to care, is perhaps the most extraordinary part of existence. Awe also brings gentleness. When we understand our smallness, anger and urgency begin to fade. The things that once seemed large, the worries, the disagreements, the noise, grow smaller against the backdrop of eternity. Perspective brings kindness. If we are all made of the same dust, if we all share the same origin in the stars, then we are already connected in ways deeper than any difference. Awe teaches compassion because it shows us that everything is one story told in different voices. The universe is not distant from us. It lives within us and we within it. There is also beauty in the silence between stars. That silence is not empty. It is full of potential, full of motion too slow or too faint for our senses to perceive. Between galaxies stretch vast spaces where light travels for billions of years without meeting anything solid. And yet, even there, the laws of nature remain constant, the same as they are here. The universe is consistent, dependable, calm. It does not hurry and it does not pause. It simply continues, unfolding like a slow breath, reminding us that stillness is also part of creation. The feeling of awe cannot be forced, it must be allowed. It grows when the mind grows quiet, when the eyes linger, when curiosity replaces control. To sit beneath the night sky, to watch the slow drift of stars, is to share in a rhythm that has existed since the beginning of time. Each point of light is a reminder of both distance and connection, of the vast scale that holds our tiny world in balance. In that moment, we are both the observer and the observed, the question and the answer. The stars do not move for us, but in seeing them we move within ourselves. The universe's beauty is not only in its size but in its patience. It has time for everything, for stars to form, for planets to cool, for life to appear, for light to travel. It moves in cycles far beyond human measurement, and yet those cycles include us. The same patience that shapes galaxies also shapes lives. We are born, we grow, we change, and we return to the world that gave us form. Each life, no matter how brief, adds something to the story of existence. Awe is what allows us to see that story with clear eyes, to recognize that every breath, every heartbeat, every moment is part of a universe in motion. When astronauts return from space, many speak of what they call the overview effect. It is the shift in perception that happens when they see Earth as a whole, suspended in blackness, shining like a jewel. From that distance, everything looks fragile, united, and precious. Problems that once seemed large become small. The boundaries that divide people disappear. What remains is wonder, a quiet respect for the planet that sustains life against all odds. This feeling is not only for astronauts, it is something anyone can find by looking up, by remembering that we live on a world that travels gracefully through the same endless sea. Awe reminds us that exploration is not only about discovery but about gratitude. The more we learn about the universe, the more we see how rare and beautiful our home is. The delicate balance of air and water, the warmth of sunlight, the presence of life, all of it exists within narrow limits that could easily have been otherwise. The universe allows life, but it does not promise it. To exist at all is a gift beyond measure, a moment of harmony between chance and law. When we look at the stars, we are looking at the same forces that made us possible, and that realization fills the heart with quiet joy. In the end, awe leads us back to peace. It softens ambition and sharpens awareness. It reminds us that to be alive is enough, that to understand even a small part of the universe is a privilege. The stars will continue to shine long after we are gone, but the light that reaches us now in this moment belongs to us. We can receive it, breathe it, and let it remind us that we are part of something vast and kind. Awe is not about answers, it is about acceptance. It is the simple recognition that the universe is whole, and that we belong within it just as we are. And so, as we drift through space or simply rest beneath the night sky, awe becomes a form of rest. It invites the mind to let go, to release the need to understand, to surrender to the rhythm of existence. The stars continue their slow dance, galaxies turn, time flows, and life endures. Everything is connected, everything is temporary, and everything is beautiful. In the vast silence, there is no need for fear, only calm. The universe holds us gently, asking nothing more than that we notice, breathe, and be. The story of our solar system, of the stars, and of our search for belonging among them, always leads back to quiet. After all the journeys of thought, all the imagined distances, we find ourselves once again surrounded by stillness. The universe continues its patient motion, planets turning, light traveling, galaxies expanding, but in this moment, everything feels calm. The questions that seem so large begin to fade into a gentle hum. What remains is not an answer but a feeling, a sense that we are part of something vast and harmonious, and that this connection is enough. In the deep calm of space, time itself seems to breathe more slowly. Every second stretches, softened by distance and silence. The The stars are not rushing anywhere, they have nowhere to go. They exist simply to shine, to give light, to remind us that even in endless darkness, brightness endures. When we look at them, we are looking into the past, into moments that existed long before life on Earth began. And yet, their light arrives now, in the present, touching our eyes and our hearts at the same time. In that meeting of past and present, we find peace, a reminder that everything across all of time is connected. It is easy to imagine the universe as something far away, separate from us, but it lives within us too. The same atoms that burn in the hearts of stars flow through our bodies with every breath. The same carbon that forms the dust of comets forms the cells of our hands. When we exhale, a part of us joins the sky. When we breathe in, we take in air that has traveled across centuries. This quiet exchange between life and the cosmos happens every moment, unnoticed but constant. It is the simplest and most beautiful truth. We are made of the universe, and the universe is made of us. If you listen carefully, you can almost hear that connection, not as sound but as rhythm. The beating of your heart, the slow rise and fall of your breath, the gentle drift of thought, all move in time with the same forces that shape the galaxies. The pull of gravity that guides the planets also keeps your feet on the ground. The light that feeds a plant's leaf is the same light that warms entire worlds. Everything moves together, each in its own way, and the balance of all those movements creates the harmony we call existence. To feel that rhythm is to feel safe, as if the entire universe is breathing with you. In space, there is no up or down, no center or edge. Everything floats in quiet equality, each thing holding its place through gravity and time. When we imagine drifting through that endless dark, it is easy to think of emptiness. But if we look more closely, we find that the dark is not empty at all. It is full of unseen light, of energy, of possibility. The quiet between stars is not absence. It is the pause between notes in the music of the cosmos. Every silence holds something waiting to be heard, and every space between things is part of the pattern that makes the whole complete. As we reflect on our journey, on distance, energy, life and time, we begin to see that the universe is not a challenge to overcome, but a story to join. We are not separate from it, nor are we its masters. We are participants, listeners, caretakers. Every bit of knowledge we gain, every machine we send outward, every dream we follow adds to the chorus of curiosity that has always defined humanity. Exploration, at its heart, is not about leaving home. It is about understanding what home truly is. The farther we look, the more clearly we see that Earth, this small blue world, is not small at all. It is enough. From the cold dust of space, our planet shines with warmth. It glows softly in the sunlight, wrapped in thin air, alive with color and motion. Every ocean wave, every forest leaf, every gust of wind is part of the same gentle system that sustains us. From far away it looks delicate, almost fragile, but up close it is filled with resilience. Life has endured here for billions of years, through storms, ice, fire, and silence. It has changed, adapted, and continued. When we look up at the stars, we are not looking away from home, we are looking at the larger family to which our home belongs. There is comfort in knowing that the universe is patient. Stars take their time to form, planets take their time to cool, life takes its time to grow. There is no rush in nature, no urgency in the unfolding of galaxies. The same patience that shapes the cosmos also shapes us. It invites us to slow down, to breathe, to rest. When we let go of hurry, when we stop trying to control every moment, we begin to move in harmony with everything else. The universe teaches us this through its stillness, that peace is not the absence of motion, but the balance within it. Perhaps one day humanity will travel far beyond our solar system. Perhaps we will walk under skies lit by other suns, and see new horizons that stretch farther than any dream. But no matter how far we go, we will carry Earth within us. The memory of rain, the pull of gravity, the warmth of sunlight on skin. These are not things we leave behind, they are things we take with us. In every breath we take, in every heartbeat, the story of Earth continues. The soil beneath our feet, the stars above our heads, the air that fills our lungs, all speak the same quiet language of belonging. The longer we think about the universe, the more we realize that it does not need to be conquered or fully understood. Its mystery is part of its beauty. The unknown is not something to fear, it is a space for wonder to live. Even if we could see every star, even if we could map every planet, there would still be questions waiting beyond the next horizon. That is the gift of existence. There is always more to discover, not only outward in space but inward within ourselves. Curiosity is the light that keeps us moving forward, gently, without ever reaching an end. As you listen now, imagine the quiet hum of the cosmos stretching in all directions. Imagine the earth turning slowly, clouds drifting over oceans, night falling gently across continents. Somewhere out there, a spacecraft glides through the darkness, its instruments silent but steady, carrying the hopes of those who built it. Somewhere closer, a leaf moves in the wind, a wave rises and falls, a breath is taken. Everything, from the smallest motion to the grandest scale, moves together. The universe is not a collection of separate things, it is one continuous motion, one soft and endless moment. It is easy to feel small when thinking about the stars, but smallness can be comforting. It means we do not have to carry the weight of everything, we only have to be what we are. A single life, a single thought, a single kindness, all are enough. In the grand rhythm of existence, every action, no matter how quiet, adds to the harmony. We do not have to change the universe to belong to it. We already do. Just by being here, by breathing, by noticing the light, we are part of the great unfolding. We do not need to reach the stars to touch them, they are already within us. When we rest, the universe rests with us. The same stillness that holds the stars also holds our hearts. The same balance that keeps planets in orbit keeps our thoughts moving in gentle circles. Rest, in this sense, is not an end but a continuation. It is the universe's way of reminding us that every motion needs its pause, every wave its calm. The act of sleeping, of letting go, is an echo of cosmic rhythm, the quiet half of creation. It is how the universe breathes through us. If you listen carefully now, you can imagine that rhythm moving through everything. It is in the ticking of the clock, in the slow turning of the earth, in the heartbeat that anchors you to this moment. The air moves softly around you, the world holds you gently in place. There is no need to reach, no need to strive. Everything that must happen is already happening. The stars will continue to shine. The planets will continue to turn. Time will continue its patient flow. And you, in this moment, are exactly where you are meant to be, safe, still, part of it all. The journey of thought, from Earth to the edge of the stars, always leads back to peace. We begin with curiosity, move through challenge, and arrive at quiet acceptance. The universe, for all its scale and mystery, reflects something simple and human, the desire to understand and the comfort of belonging. Whether we travel through space or simply close our eyes and imagine it, the effect is the same. We feel the vastness and we find calm within it. We see the distance and we recognize connection. In that balance there is rest. You can let your breathing slow now, matching the pace of the universe around you. Each breath in brings calm, each breath out releases weight. The stars above, though distant, glow softly as reminders of time and patience. Their light has crossed impossible distances just to arrive here, now, in this moment with you. You do not need to go anywhere. You are already among them. The light that fills your eyes is the same that fills the galaxies. It is ancient and new, distant and near, and it will always be enough. As you drift into stillness, imagine the quiet sea of space around you, not cold but peaceful, not empty but full of calm. Imagine yourself floating gently, surrounded by stars, each one a small heartbeat in the darkness. There is no noise, no urgency, no separation. Only light and the deep comfort of knowing that you belong to it. The journey has brought you here, not to an ending but to a resting point within infinity. Everything continues, but you may rest now, carried safely in the same rhythm that guides every world. The universe holds its breath with you. The stars shine softly, patient and eternal. The night surrounds you steady and kind. You are part of it, all of it, and it is part of you. There is no need to think or to move. Just breathe. Just be. Let the vastness become silence, let the silence become sleep. The light of distant suns will watch over you, gentle and unwavering as time drifts onward and your thoughts fade into peace. If you're enjoying this, feel free to subscribe or leave a like if you'd like. Thank you for sharing this quiet journey. Wherever you are, beneath the same stars, may your rest be deep, your dreams kind, and your heart at ease. The universe is wide, but for now, all you need to do is close your eyes.